Welcome back, everyone, to the deep dive. This time, we're taking a deep dive into the world of LLMs.
Yeah,
Large language models.
yeah.
All the rage these days, and for good reason.
Yeah.
We've got this handbook here, jam-packed with insight into these AI systems that can understand and generate human language.
It's amazing to think
It really is.
how far we've come from those early days of, you know, clunky machine translation to AI that can practically write a novel.
I know. This handbook actually mentions those early machine translation attempts, like back in the 1950s.
Oh, yeah, those were pretty basic.
Yeah.
Like just word-for-word substitutions, really?
Not very sophisticated.
Not at all. But hey, got to start somewhere, right?
Right, those are the first baby steps
Exactly.
towards teaching computers how to actually understand what we're saying.
Mm-hmm.
So how did we go from those, kind of awkward early attempts
Yeah.
to the AI that can, like, hold a conversation with you, compose music, even write code?
Well, there were some major breakthroughs along the way.
Okay, like what?
Well, one of the big ones was Word2Vec. That emerged in 2013, and it was a real game changer.
Okay, I've heard of Word2Vec,
Yeah.
but to be honest, I'm not entirely sure I understand what it is.
So before Word2Vec, we were trying to teach computers language by basically giving them dictionaries and grammar rules,
Like the traditional way we learn.
Exactly.
Okay.
But Word2Vec, it took a different approach.
Okay, how so?
It started representing words as vectors in a multi-dimensional space.
Okay, I think I'm gonna need you to break that down for me a little.
Right, sure. Imagine a map, but instead of cities, you have words on this map, okay?
Okay, I'm picturing it.
Words that are similar in meaning would be clustered closer together.
So king and queen would be close together.
Exactly. Or happy and joyful, those would be neighbors too.
I see. So it's all about relationships between words.
And here's the really cool part.
Okay.
You can do math with these word vectors. You can actually add and subtract meaning.
Wait, hold on. You're saying we can do math with words?
Pretty much. And that ability to represent words as vectors, that's what allowed computers to start understanding the relationships between words.
Not just their individual definitions.
Exactly. Huge leap forward in natural language processing.
So Word2Vec was like giving computers a sense of semantic meaning. Is that right?
You got it. And that paved the way for even more sophisticated models.
More sophisticated.
Like the transformer architecture.
The transformer architecture.
Came along in 2018.
Okay, this handbook calls that a fundamental shift in how AI processes language.
It really was. It changed the game.
So what was so different about the transformer?
Well, before transformers, most AI models process language sequentially, word by word,
Kind of like reading a sentence one word at a time.
Exactly.
Yeah.
But transformers introduced this concept of attention.
Attention.
Yeah. Basically, it allows the AI to look at entire sentences or even paragraphs at once.
So it's like the AI is finally reading between the lines instead of just focusing on individual words.
Exactly. And that was a game changer because it meant that AI could understand the context and the relationships between words in a much deeper way.
And that led to?
That's what enabled the development of the large language models we know. And let's be honest, sometimes love to hate today.
You're talking about models like GPT.
GPT.
And BERT.
The celebrities of the LLM world. Let's start with GPT, developed by OpenAI. It seems like GPT is everywhere these days. What makes it so special?
Well, one of the key things is how it's trained. It's pre-trained on a massive data set of text and code.
Right.
We're talking billions of words.
Wow, it's read every book, article, and website on the internet.
Pretty much. And that gives it a huge vocabulary and an incredible understanding of language patterns.
No wonder it can generate such human-like text.
Right. And then once it's been pre-trained, you can fine-tune it for specific tasks.
Fine-tune it, like tailoring it.
Exactly. Like, say you want GPT to write marketing copy for your business.
Yeah.
You can fine-tune it on examples of good marketing copy, and it'll learn to generate something similar. That's incredible. So it's like a multi-talented performer, this GPT.
It really is. And then there's BERT, which is a bit different.
Okay, what's BERT's claim to fame?
BERT is all about understanding context.
Context.
Yeah, it's really good at figuring out the nuances of language. How the meaning of a word can change depending on the words around it.
So, like, if I search for bat on Google, BERT helps figure out if I'm talking about the animal or the baseball bat.
Exactly. BERT's ability to understand context has made search engines much more accurate.
And chatbots, too, I imagine.
Oh, absolutely. It's made them much better at understanding what people are actually asking.
Wow, these models are already incredibly powerful. But I'm curious, how do they actually work? What's going on under the hood?
Well, let's break it down into a few key concepts. First, we've got tokens.
Tokens.
Yeah, imagine you take a piece of text and break it down into its smallest units. Words, punctuation marks, even parts of words sometimes.
So it's like taking a sentence and turning it into a set of Lego bricks that the AI can then play with.
That's a great analogy. And just like you can build different structures with the same Lego bricks, an LLM can generate different outputs using the same set of tokens.
I see. Okay. And then there are those word vectors we talked about earlier, the embeddings.
Right. Remember how we talked about words being like points on a map?
Yeah, with similar words clustered together.
Exactly. Well, each token, whether it's a word, punctuation, or part of a word, gets represented as an embedding.
Okay, so it's like giving each token a unique fingerprint that tells the LLM everything it needs to know about that token's meaning.
You got it. And then all of this processing, the tokenization, the embeddings, it's all powered by neural networks.
Ah, neural networks,
Huh.
the brains of the operation. This handbook talks about neural networks being layers upon layers of interconnected nodes.
Yeah, it's a bit mind-boggling to imagine.
It is. So how do all those layers actually work together to process information?
Well, imagine a network of units, all interconnected, each one making a simple calculation based on the input it receives. These units are organized into layers, and each layer has a specific function. And the magic happens when these layers work together, passing information back and forth, refining their calculations based on feedback.
So it's like a chain reaction,
Yeah.
with each layer building upon the work of the previous layer.
Exactly. And the more layers you have and the more data you train the network on, the more sophisticated the AI's understanding of language becomes.
It's incredible to think that all of this complexity is happening behind the scenes, allowing these models to generate such fluent and nuanced language.
It really is remarkable, isn't it? And we've only just scratched the surface of what these models are capable of, and it's just going to get more amazing from here.
Oh, how so?
This handbook talks about multimodal LLMs.
Multimodal LLM.
These are models that can handle not just text,
Ah.
but images, audio, even video.
Whoa, hold on.
Yeah.
So they're like breaking down the barriers between how we experience information.
Exactly. It's not just about words anymore.
So what can these multimodal LLMs actually do? Any cool examples in the handbook?
There is one I think you'll like. It's about OpenAI's CIP model.
CIP.
Yeah, it can match images and text with crazy accuracy.
Like how?
Imagine searching for an image not with keywords, but by describing what you see.
Like a cat wearing a tiny hat riding a Roomba.
Exactly. CLIP can understand that kind of description and find a matching image.
Wow. So it's like giving computers the ability to see and understand the world the way we do.
That's the idea, and it has huge implications for like image recognition, content creation, even accessibility for people who are visually impaired.
That's pretty mind-blowing.
It is. And then the handbook talks about this other really interesting thing.
What's that?
Domain-specific fine-tuning.
Okay, domain-specific fine-tuning.
Yeah, so basically
okay,
you
yeah.
can tailor LLMs for specific fields like medicine or law.
Oh, so it's like specializing.
Exactly. Like you take a general purpose LLM, like GPT,
Right.
and then you train it further on a huge data set of medical journals, textbooks, patient records.
It's like sending the LLM to med school.
Exactly. And then you end up with an LLM that can analyze patient symptoms, maybe suggest potential diagnoses, even assist doctors with treatment plans.
Wow, so it's like having a medical expert at your fingertips 24/7.
That's the idea.
Right.
But it's not about replacing doctors. It's more about giving them a powerful tool to enhance their decision-making.
That makes sense.
And the handbook has some really cool case studies in other fields, too.
Like what?
Well, there's one about law firms using LLMs to automate document review.
Okay.
Traditionally, document review, it was super time-consuming for lawyers.
Yeah, I can imagine.
But now an LLM can scan thousands of pages, like legal documents, identify key clauses, flag potential issues, all in a fraction of the time.
So it's like having an army of legal assistants.
Exactly, but ones that never get tired or need coffee breaks.
Right, so this frees up the lawyers to focus on the more interesting stuff.
Yeah, like developing legal strategies, advising clients.
This all sounds amazing, but
Yeah.
I'm guessing there are challenges too, right?
Oh, for sure. I mean, one of the big ones is the sheer computing power these models need.
Like how much power are we talking?
I mean, these models have billions, even trillions of parameters.
Bro.
And training them can take weeks, months even.
And a ton of electricity, I bet.
Oh, yeah. So not everyone has access to that kind of computing power.
So while the potential is huge,
Yeah.
there's a barrier to entry for like smaller companies or research groups.
Exactly. And it raises questions about, who gets to benefit from this technology.
Right, the accessibility issue.
Exactly. And then there's the data issue.
Oh, right. These models are data hungry, aren't they?
Super data hungry. But what if that data is biased or incomplete?
That's a problem.
A big one.
Yeah.
Because then the LM might perpetuate those biases.
Like, imagine an LLM trained on a data set of, like, news articles that are skewed towards a certain viewpoint.
Exactly. Then the LLM's output might reflect that same bias.
And that could lead to unfair or discriminatory outcomes.
Exactly. So it's not just about the size of the data, it's also about the quality and diversity of the data.
And ensuring that it's representative of the real world.
Absolutely. And this isn't a one-time fix either. We need constant monitoring and evaluation to make sure these models are performing fairly.
So it's an ongoing process.
It is. And then there's the challenge of ambiguity and context.
Oh, yeah. Human language can be so tricky.
It really can, full of nuanced double meanings, sarcasm.
Can LLMs really grasp all of that?
Well, they're getting better at understanding context, but they still struggle with things like sarcasm, humor, figurative language.
Right.
Like, imagine trying to explain a joke to someone who doesn't share your sense of humor.
It just falls flat.
Exactly. And that's why it's so important to remember that these models are still tools.
Right.
They're not a replacement for human judgment and understanding.
So we might be impressed by their ability to sound almost human, but we shouldn't forget there's still a gap between machine intelligence and human intelligence.
Absolutely. We need to keep that in mind as we develop and deploy these models.
But despite all these challenges, the progress is still pretty remarkable, isn't it?
Oh, it's mind-blowing. I mean, what's next? What's on the horizon for LLM?
Yeah, what is next?
Yeah.
What has you most excited about the future of LLMs?
Well, one thing that I find really fascinating is real-time processing.
Real-time processing?
Yeah, like imagine LLMs that can not only understand and generate text, but do it in real time, adapting to the changing context of a conversation.
So like an AI partner that can keep up with your thoughts and respond in a truly dynamic way.
Exactly. And we're starting to see progress towards that with models designed for chatbots and virtual assistants.
That's pretty cool.
It is. And then there's the ongoing development of multi-modal LLMs.
Right, the ones that can handle text, images, audio, video, all of it.
Yeah. Think about it. Searching for information, using not just text, but images and sounds.
That's crazy. Or interacting with virtual assistants that understand what you're showing them, not just what you're saying.
Exactly. It could revolutionize how we interact with information and technology.
Really could.
And it's not just about information retrieval either.
What else?
Think content creation.
Okay.
Imagine tools that can help you generate videos, music, even virtual worlds just based on your descriptions.
It's like a whole new world of creative possibilities.
Exactly. And it's not just for professionals. These tools could empower anyone to become a creator.
It's exciting and a little bit daunting, too.
It is. It's like we're standing on the edge of a new era.
An era powered by LLMs.
Yeah, but with any powerful technology comes responsibility.
We've got to make sure we're using it wisely.
Absolutely. Yeah, it's like all this potential, but also a lot of responsibility.
Definitely. We've talked about the technical stuff, but this handbook also goes into, like, the ethical side of things.
Right.
What are some of the big ethical concerns around LLMs?
Well, one of the biggest ones is jobs.
Jobs.
Yeah, job displacement.
Oh, right. Like, as LLMs get better, they could start automating jobs that humans currently do.
Exactly, like writing reports, analyzing data, even customer service.
So some people might be excited about AI taking over those kind of boring tasks,
Yeah.
but others might be worried about, their livelihoods.
Yeah, it's a tough issue. No easy answers there.
Right. It's complicated.
It is. And then there's a whole issue of misuse.
This use of LLMs.
Yeah, what if someone uses them to generate fake news or spread misinformation?
Ooh, or create those deep fakes that look so real.
Exactly. That's scary stuff.
Yeah, it's like giving someone a powerful tool without any safety instructions.
Right. And it's not just about intentional misuse either.
What do you mean?
There could be unintended consequences.
Oh, okay.
Imagine an LLM that's designed to personalize advertising.
Yeah.
But it ends up, inadvertently perpetuating stereotypes or discriminating against certain groups.
Oh, wow. Yeah, that would be bad.
So it's not just about the technical capabilities. We also have to think about the ethics.
Right, and make sure these LLMs are being used responsibly.
Exactly. It's on all of us. Researchers, developers, policymakers.
And just society in general.
Right. We all have a role to play.
So it's not just about building smarter AI, it's about building more ethical AI.
You got it. And that's where things like explainability and transparency come in.
Explainability, transparency.
Yeah, like we need to be able to understand how these models work, how they make decisions.
So we can identify any biases they might have.
Exactly. And we need ways to hold people accountable, the people who develop and deploy these models.
Right, so that they're using them ethically.
That's the goal. It's a big challenge.
It is, but it sounds like there's a lot of work being done in this area.
There is. People are definitely aware of these issues, and they're working on solutions like ethical guidelines, best practices.
That's good to hear.
It is. So, want to shift gears a bit, talk about some real-world applications.
Sure. This handbook has a bunch of fascinating case studies.
It does. Any that really stood out to you?
Well, there's one that I found really interesting.
Oh, yeah. What is it?
It's about a hospital using an LLM to help doctors diagnose rare diseases.
Oh, wow.
The LLM was trained on tons of medical data, and it was able to spot patterns that human doctors had missed.
So it's like a medical detective helping doctors make more accurate diagnoses.
Exactly. And in this case, the LLM's insights actually helped doctors come up with a more effective treatment plan.
That's incredible. It really shows how LLMs can augment human expertise and really make a difference.
Especially in critical fields like healthcare,
Absolutely. And there are examples in so many other industries, too.
like education, finance, customer service.
It seems like LLMs could potentially transform almost every aspect of our lives.
It does, doesn't it?
It's both exciting and a little bit daunting to think about.
It is.
Yeah,
It feels like we're just at the beginning of this whole LLM journey.
we are. And the more we understand about them, the better equipped we'll be to deal with the challenges and the opportunities they bring.
Well said. So to everyone listening, thanks for joining us on this deep dive into the world of LLMs. Keep learning, keep exploring, and we'll catch you next time.